Okay, Assalamualaikum and good morning. As promised, uh, we will continue basically with question. I want to concentrate on question 4 that is still on mole concept and will include a little bit of calculation including molarity today. Okay, let's have a look at question 4 here. I have question 4. As you can see here, question 4. It says quinine C20, H24, and 2O2. That is the molecular formula. Okay, and is a compound extracted from cinchona tree, which is traditionally used to treat malaria. If a given 1.08 gram of quinine sample, calculate first the molecular mass of quinine. I think that question is easy enough, senang je. Okay, molecular mass. Okay, what do you do? As usual, okay, 4A. Oh, sorry. The ink is so fancy. I think I better change it to black. Okay, 4A, we have molecular mass. That is, I've calculated the molecular mass. So you total up, okay, MR is just 20 times 12 and so on, yeah, plus 24 times 1 plus 14 times 2, and lastly we have 16 times 2. And is there any unit for this one? It says molecular mass, right? Without the word relative, in this case the unit by right should be, yes, correct, AMU. So you calculate and see what's the figure here. Now, the relation comes in part B, yeah? What? Not really relation, but in 4B, it says you need to calculate the number of mole. The number of mole is basically what you have here is mass. You are given the mass, and from part A you have the molar mass, because molar mass is basically the same value as molecular mass, only in different unit. Okay, if you calculate the molecular mass at the top, the value is, okay, 1 mole of quinine the mass is 324 gram. But do you have 324 in this case? No, the value is 1.08. So where do we put the 1.08? This side or the other side? Yes, correct. It is on the mass side, on the side which have the same unit. So here we put our 1.08. Right, and we can now calculate our number of mole. You can either put X, you can put N actually. N is the standard symbol for number of mole. And you can calculate the number of mole here, quinine. Okay, I think we have seen this in class before. Quinine is what? You have 1.08 times 1 over 324 grams. Or sometimes maybe you are so used to using the formula that is mass over molar mass. So in this case, you can also use that formula but be familiar with this kind of writing. Alright, so in this case, I'll show you the example. 1.08 grams times 1 mole over 324 gram. You cancel out the unit of gram and you get the unit of mole. Now, what do you get here? Okay, if you calculate, you should get a value, right? And remember, the value must have enough significant figure. Yeah, enough significant figure. If not, it will affect the answers of part C, D, and E. Right, let's continue. Okay, what do you get here? You tell me in group. Okay, and then, okay, can we continue with part C? Okay, C, it says you need the number of molecules of quinine. Okay, remember what I mentioned about mole relation. Mole and it wants number of molecule here. Yeah, it wants number of molecule here when you have the number of mole. So you think of the relation. What is the relation between mole and number of molecules? Molecules is equivalent to particles, right? So mole and particles. 1 mole, okay, 1 mole of quinine contains 6.02 times 10 to the power of 23 molecules. Right. But do you have 1 mole in this case? No, you only have this much of mole that you got from B. Yeah, so substitute that here because we have mole and down here must also be mole. If you calculate, it would be around 0.00333. Remember, yeah, you must have enough significant figures. And you can calculate the number of molecules. Okay, fair enough? This value here, you substitute here. Are we okay? Okay, if you have any question, feel free to ask. Yeah? Okay, now let's continue with D. Okay, I hope you can do E yourself. Actually, I have asked you to try, right? But no problem. Okay, I think maybe I'll clear the canvas a little bit so that the screen is bigger for you to see and you can refer to the question yourself. Yeah? Okay, now refer to question D. It says you need D. You need the number of hydrogen atoms. But what do you have in this case? What do you have previously? Okay. From part B, you have the number of moles of quinine. And from part C, you have the number of molecules of quinine. Which one do you use? Actually, you can use either one, no problem. But remember, whatever it is, normally you relate substances in the form of mole, which will be much easier for you. Yeah? Okay. What do we know from the formula? The formula of quinine is C20, H24, N2, O2. Right? What do we know from this formula here? What can we see? Now, we want hydrogen. How many hydrogen does it have here? 24. So that is what we know just by looking at the formula. 1 mole of quinine. Sorry. Sorry, dia main lari-lari pula ni. Okay. 1 mole of quinine contains how many mole of hydrogen? 24, yeah, mole of hydrogen. Do you know the number of mole of quinine? Yes. From part B, you know that the number of mole of quinine is 0.030000333. Okay, you need to calculate this. And now you can calculate the number of mole of H. When you get this answer, is our problem solved? No, not yet, because we want the number, the number of hydrogen atoms. Okay, fine. We have the same subject now. Mole of hydrogen and number of hydrogen. Okay, what do we do? What's the relation between mole and number of hydrogen? Correct. 1 mole of hydrogen contains 6.02 times 10 to the power of 23 atoms. Now you can substitute this here. Okay. We know the number of mole and we want to calculate the number of hydrogen atoms. Are we okay? Right. So you can basically tell me what you get for B, C, D. I mean the final answers. And you can try to calculate E yourself. I give you 10 minutes, 5 minutes, 10 minutes to solve this. Okay. So see you again later. Yeah.